All right, I figured it'd be fun to stream this while I work on figuring out why the heck my CRC system is not matching this one. All right, so we have an index file, which on mine, it's 49, and on this, it's also 49. Then we're gonna do a CRC run. Originally it was 0 on both. So we'll go and hit continue. CRC is now 350. Let's hit continue on this as well. And you'll notice the CRCs are the same still. 350-561-4887. And we're currently with the name length of 9. This has a name length of 10. Is there a 0 escape on the end? Is that what's causing the issue? It's very possible. You know what, before I even continue, let's put a 0 padding on the end of each of these checks. I think that'll do it. It says it failed, but what failed? It just failed. I might have fixed this actually. Okay, so we're going to remove this. What do we get back now as a CRC? 239. We're still not accurate. Let's continue just to make sure. Okay, so the value should be 248, blah, 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 blah. And we get 293. Okay, so this is still worth doing. All right, so let's go back to here. And let's double check that the 0 padding is added proper. Okay, so name length is 9, name length is 10. Name is just onedirt.bmp. Wait, where did my 0 go? I thought I added that. Oh, it helps to actually put it on the string. Okay, so the length of the string is 10, and the length of the string is 10. Currently, CRC is set to 0 for both. Let's go ahead and continue on both. Okay, so CRC is now 156, and CRC is 350. What? Oh, I might have gone over one more. So now it's 156, 156. Okay. Yeah, the pointer was not in sync. So let's go ahead and continue again. Now we have 238, 238. The file name is onedirt.bmp with an escape or null terminator on the end. And you can see your onedirt.bmp with an x00 on the end, which is about basically the same thing. We're going to go ahead and get to the return point on both. And this is the real check. So we have 248, 793, 860, which I think we figured it out. Pass. Wow. Okay. Well, that was the point of this meeting was, or this stream was, I was going to show how I'm going to debug the CRC test. But apparently all I need to do is pad a 0 if it doesn't exist. So what we need to do now is I'll probably do a file name CRC check addition. I'm also curious if I can make the file name 2CRC works. But before that, if name, length of name does not equal, then name plus equals this should pad the 0 if it doesn't exist. because the CRC requires that, and by default it does not do that. So let's try this one more time. Let's just make sure it passes. Nope, index out of range. Oh, -1. Success. Okay, so now let's do file name 2 CRC and see how close we are and if it fails. Yeah. We wanted ED and we got F9. Let's double check if IEEE works. I don't think it will. It's not a big deal. We got this working anyways. Yeah. So we're going to go ahead and remove this. We basically generate the hash by hand, and that's fine. But cool. So now we have a CRC generator that actually works. Okay, so the next big challenge with my PSS loader is the chunks that it's generating. Unfortunately, they're not matching what this program does. So we're going to have to figure out a way to debug that. Since right now, EQArchive has a function called save, which ultimately saves to the directory. And basically is writing all this stuff. And the part that we're going to have to learn, we could probably just walk through this entire code. Okay. So let's go ahead and open up, for testing, arena.s3d. And we're going to save it as arena2.s3d. And this should breakpoint. Boom. Okay. So now we go back to my code. We're going to have to go find arena.s3d. Right here. Oh, it's actually exporting all the files, isn't it? Or I guess Arena 2 is a legit file. It's a little worrying. Whoops. It's okay. Anyways, what we're going to do is we're going to make a test folder real quick. We're going to do the PFS test here. And then here we're going to put the arena.s3d. And we're going to set it here. Okay, so after we load and we extract, we're going to try to do a save operation. And when I do a save operation, this code basically needs to be checked in comparison to what this is about to do. Okay. So right now, we're about to create a file with a binary writer. Let's go ahead and make this trigger now with the debug. Okay. So we're going to be iterating all the files. There's 10 total, which this also knows that there's 10. Okay. We're going to be generating CRCs and doing all sorts of fun stuff. We're going to go ahead and hit continue. Let's go ahead and breakpoint on the next milestone, which is we have files by CRC. Let's make sure the sorting works right. Okay. So PFS files has this. And this, is there a way to make this stick? I thought there was. There. But I can't see the data unless Ugh. So claw. Okay, this is not very intuitive. Isn't the files by CRC here? Okay, here we go. So we got claw, one dirt. Claw, one dirt. And just for fun, let's get to the very last one and make sure the order is the same. Palette, palette. Cool. So far we are identical. Okay. So we're going to be starting a stream up to start creating the Binarywriter. And we're going to first start writing the number of files. And then we're going to be iterating each entry. Did he write the header already, or does it skip that? So we have underscore file here. And that's used for directory bytes. So this is priming in a subbuffer for the directory bytes. And then it'll take the header, set the values, and then it'll take the size of all the compressed chunks and their two size values. So this is a part where I'm going to have some difference. Because I actually did all the compression up here. And this code is heavily theory crafted, so I'm going to need to review this pretty heavily. All right, so we're just making a directory buffer. I mean, I could replicate this. There's nothing wrong with refactoring a little bit of this code to fit how this other one works. Because basically what we need to do is that we sort the CRC files. We generate the CRCs as well. Directory index, I actually calculate, which he does not, but regardless, this is the part I care about. Directory bytes. We're going to call this, we're going to start a buff. Like that. And what it writes out is the count. Is this literally the... Yeah. And we're just going to be... I don't know if we need to use length though, or if we do use length, we have to change it to a uint32. That's what it's doing too. So the length of PFS files. And I think conversion is this. Okay, so length isn't going to work because I think you actually, to convert, you have to wrap it like this. There we go. Okay, so we're now iterating all the values of the file names. Okay. Why wouldn't I just do it up here? I'm going to shift this a little bit just because we can take the directory buffer. We're iterating it already. We're doing all this other fun stuff. Oh, it's because I haven't sorted it yet. Never mind. Fine. So we're going to go ahead and range over the files again. And we're going to write into it. Notice that it says the length +1, and then it writes the data. Okay, so this is the header telling it how much the upcoming bytes are. So let's do the same thing. So we take the length of the entry name, we add 1 to it, and we add this to the directory buff as a binary little endian. What did I just do? Okay. Why can I write to directory? Oh, I missed a Y. Give me 1 second. My other laptop's going loud. There we go. Cool. So we are now going to be converting this to uint32. I'm pretty damn sure that's what he did too. Yeah. I'm going to go ahead and push this to the left, take the debugger, put it to the right. We're going to turn that off, and now we can see both in parallel. Good. Okay, so now we have the length of each file, and then we could also add the W, but screw it. Let's just why do I keep pressing page down? How annoying. I'm like not used to this keyboard or something. Right. Okay. These will never error, but I like having it there anyways in case there is ever an error. So now we are writing the directory size is going to be based on the current position. Why would I need to keep putting that? Oh, it's because this is going to become... Is this used elsewhere? Find all references. No, we resize, we set it, and then we initialize it. So this is not used on mine because we already know the size. And we don't need to do an array resize. This is a buffer. And we don't need to do set contents either, because we're just writing this directory as we go, like so. Okay. So now we've done the CRC, we've written that stuff, and now we move on to the header, which my old way I did all the data there. I think my load, I actually took the header. Nope, I still have it raw. That's fine. think my header's okay. Directory index. This part is going to have some issues. Because the index pointer, we don't fully know yet. And that's what this is doing. And this is based on the number of compressed chunks, which unfortunately, I technically know already. Start with the size after the header itself. Okay. So directory index is 12, and this is, offsetting all the other things. And now we're going to range over the files, and we're going to put the directory index offset by times compressed chunks equals nil, otherwise well, here, let's just do this. Oh, is that why? Okay, so we're going to go into entry real quick. We're going to add a new entry to PFS entry. We're going to have so whenever we do a compress function and we're going through doing all this, we're also, damn it, I keep pressing page up instead of home. We're also going to have a, not E, deflated total size plus equals CE deflated size. There. And what that's going to do is now oh, I'm storing this in the wrong spot. I think it should be under CE, which CE is the chunk entry, right? These are the deflated entries. We want it in E because that's the PFS entry. Why is it unhappy with this? Is it because the, well, yeah, we don't need to do length, that's why. There. Now we have essentially the same thing. I know my compressed bytes are going to be off because my compression step's broken, but now it's going to be easier to repeat. And then add in the size of the compressed file name directory and its size value. Ew. Okay, so wait. Directory says compressed chunks. This is for the directory names. I think set contents is doing a compression step on it. Yep. Shit. All right, this makes more sense. I don't like generic functions that don't tell you what it's doing. So we're going to need to go in here, find we're going through, we're taking directory, we got it raw now. What we could just do is compressed, or how about directory compressed buffer. I don't know if this is the smartest way to do it, but we could try it. And by default, we're going to start it with a new buffer, and that's going to be the directory buff bytes. The other problem with this, though, is that each chunk is basically an array. And so now I have to store, I need to store a chunk array. I could just invent one real quick, because I do use chunk. In PFS entry. Man, this is getting gross. I'm gonna have to sit back, review this all, and clean it up. But now I know where I'm going, and I can tweak this more. Basically, what I'm going to need to do is adjust this. Like, I have this file name pointer, and I'm pretty sure this is only towards the end, and I use it for finding. Yeah, this is not proper anymore. What we're going to need to add is some sort of chunk. Something like this. And chunk is used twice because PFS deflated entry is going to become chunk entry, actually. And it's not necessarily deflated data, it's chunks. And I'm renaming that because it's a little confusing. Because the deflated and inflated is done in the chunk entry. So we have the raw data, the raw data gets compressed into chunks. Each chunk will have a deflated side, an inflated side, and then the raw data of the chunk, which has obviously been deflated because the raw data is the extracted form. Okay, and now that I've done that, directory chunks is going to also need a directory chunks total size. There. And what that's going to do is after we iterate all the files and get their header info done, we're going to have to take a do a compress operation similar to what we do on the PFS entries, and do it in directory chunks, which right now is called chunk entry, but I could just call, it's going to be similar, I think, in this code. Can I genericize this? Let's see. We get a byte buffer, we get the length of whatever the data is that comes in, and then we just append it to this chunk. Yeah. So what we just can do is do compress, and then be like data, right? And damn it. We need the data. And then when we return, we want to return with a bunch of chunk entries. There. And what this does is now we don't need E data. Like, do we ever use E other than for data, other than chunks we set? Yeah, so we can just go take the length of data, iterate each element. Man, I am having word typo galore. Start up a new array. There. And this compress function doesn't need to be under PFS entry anymore. How about deflate chunks? Sure. Okay, so now we have, chunks total size. Also needs to be returned. Okay, now we're going to have chunks total size, and error by calling compress, and we send the entries data over. Now we can set entry chunks to chunks and entries chunk total size. In fact, we don't need to do this. There. Okay, what am I messing up? Undeclared name compress. Oh, it was chunk. What was it called? Deflate chunks. There. So now we call the deflate function and it chunks it up. We can put it into our array elements. we're done. Now when we go to directory, we can do a similar operation, but this time we can set it directly to the PFS. Why are you erroring and then not giving me? That's annoying. And this is going to equal deflate chunks for actually this is just going to be the directory buff, I think. Ta-da! Okay, so now that we got that going, we are now deflating all the directory chunks into this. And they are intentionally lowercase. In fact, I can make these also lowercase because they're not really operations you'll be doing outside of my personal zipping. Cool. And in theory, though, this will make... Man, this code does not indent right. Like, I hate the 5 indents, you know? 3's even a little high, but like 1, 2, 3, 4, 5, 6 indents. Anyways. And I can't scroll right for some reason. Like, there we go. All right, so we got directory chunks, which is basically what this is doing. There is a check that basically says if the chunks is 0, then set it to 1. But we're not going to worry about that for now. Add in the size of the compressed file name directory, and its size value is also an offset for this, which we started to do. I think we were just reviewing all this. So directory index is currently 12, right? None of this is impacting the directory index yet, because until we have the chunks, we can't do this step. Right? Index pointer uses directory. Index pointer also uses every file entry. Okay, so it's this code that it's talking about right now. Okay, then we do directory index plus equals. Why did I do the 4 during the file entries? That's not right. Oh, it is right there. Okay. Times we're going to be doing this code again, this time for directory chunks. And then we add directory buff length. Right? 4 plus 4 times the chunk size plus the directory length. But this is when it's compressed. So this is actually the total size. Okay, so now we write the header. Magic number, version number. Then we write the compressed file chunks. Then we write the compressed directory. Which is pretty much the same thing. Instead of chunk, or you know what, we can call this chunk. And instead of entry name, we'll have to index this. Oh, I already do index this. There. Why is this error? Oh. Okay. Then we write the index of file entries. Which is the file count plus 1. Then we go through each file KVP file pointer. Where did file pointer get created? Interesting. Why would it store it right after we iterate the files by CRC and compress them? Well, let's just honor that. That would be OS seek. Wait, why do I remember? I'm trying to remember what the seek command's under. Why am I having a brain fart? It's W. Oh, it's on the writer itself. And then it's like IOC current. If error is nil, return. Oh, come on. I don't like my keyboard. Seek directory chunk index. All right, so now we have this file pointer, and this is important because after the CRC files, Oh, every entry file pointer is written right when the file gets started. Okay, so entry file pointer. Okay. Then we have directory file pointer, which is what we're just setting here. Now we write the number of files. After we write the file list. Okay, so this is the key entry. What is key again? I don't remember what key is. Oh, it's the CRC apparently. Huh. Okay. Well, let's just range over the files and do what it's saying, which is entry CRC. So there is binary write W binary little Indian, and we're going to write out the entry CRC. Writing out entry or file CRC failed because reason. All right, now we write the file pointer. And lastly, we write out the uncompressed size. What is this? It says it's a uint32, but that looks like 1, 2, 3, 4. Oh, I guess it is. All right. So now we write out, sure. Okay. Now we write out the file pointer. The file pointer of directory. Where did I put that? Isn't it this? And now we write out how much the directory will be uncompressed. Ooh, do I even have that number? I think during a compress command, you know, I could just calculate it real quick. It's not hard. Okay. Now we write a PFS footer, which is literally just the word Steve. And then we write a date stamp. How's the date stamp formatted? As a uint32. Weird. How do you get a date stamp at a uint32? What are all the references to this? And it doesn't really tell us. Well, it's a simple uint32, so zero. Sure. Actually, let's put 69. Why not? And then we're done. That's fine. That should fix that. All right, so let's go ahead and run a test real quick. And it succeeded. Now this will write out this file. And we get to see just how messed up it is after all that fun. Hey Zachary, what is EQZXC CRC? Hey dude. Wow, there's a lot of people talking. Sorry, I don't have it all set up. I'm coding in Go, Fanar, and yes, and assuming you guys can't hear me. ZXCRC was an issue I was hitting with making file name CRCs match when I compress S3Ds. Got it sorted at the start of the stream. Cool. I need to get Restream working again so you guys actually can be seen. I'm going to turn the screen off for just a second. It should be fine, but I don't want you to see my password if I accidentally put it in. So give me just a sec. I know my video or audio is coming through, but I just figured I'd text it as well. All right. I need my Restream account. gmail.com. What the fuck? It's making me do a CAPTCHA through the overview. Okay, boats. I can't see more. Click the bicycle. Traffic lights. Thank you. Got it. All right. Wait, why are you dragging? Can't tell where it's at. Okay, there it is. All right, so now hopefully this thing's connected and your guys' chats will relate to that so I can see it without watching. Yeah, looks like it's working. Cool. So let me put my capture back on. Sorry for the mirror effect. And now I have a little transparent window showing me what you guys are saying. So apologies for the delay. So basically what I'm doing is I'm taking EQZip codebase and I'm converting it to Go. And you ask why? Well, I'm a lot more comfortable in Go. It kind of lets me wrap my head around it. And a lot of these programs are crashing and they're not giving errors and they're about as cryptic as can be. and they're a pain in the ass to debug, they're a pain in the ass to compile. So I was like, you know what, screw it. You'll notice all of my Go code, every single line, if there's a failure, you're going to get a verbose reason on why. And that's pretty much my biggest motivator. I want to know exactly when an issue happens, where to find in the code that issue happened, so I can just code in the patch. I should actually write a quick S3D parser of every file in the directory and see also if it can do EQG. But I was going to first finish my saving code, which I just wrote a potential version of. All right. Plus, I like testing in Go. All right. So we have an arena file, right? Arena.s3d. It goes in, it extracts it. And then after extracting it, saves it. Really taking initiative on new EQ zones, I see. Yeah, I mean, so here's the thing. OpenZone is old. It's like 2008. The code is very comprehensive and nice, but it's all in Pascal. It's actually been converted multiple times already, essentially, including EQZip was inspired by it. Everyone gives thanks to that. But what I would love to do, as this README said on this project, is being able to just take an EQG, an S3D, or PFS, right? Parse world data, convert to a raw format, .map for Quake 3 editing, whatever I can to make these files manageable. GLTF or 3ds Blender editing, and I'm gonna actually put this like this. And then I also want to use TOML for property changing. That isn't supported by third-party clients. The lights would be in that realm. That was their OpenBSP. And then when you're done editing, right, what you could do is run EQZXC, target a PFS archive, then run EQZXC, target a extracted PSF archive, and parse map files, etc., TOML, etc., and repack to EQG, S3D, pack, etc. So yeah, there you go. That's the real goal of this program. You just run the program in your EQ directory or any directory you like. It will take an EQG, S3D, all that, and it'll create paths in your, just like this. You can see here, I have my arena.s3d file here. When EQZXC runs on it, it creates a underscore arena.s3d folder above it. You see that? And when you open this, the idea is it's going to take your world data, convert it over to map data, or whatever conversion makes the most sense. And any data that can't be converted will be in these TOML files that will define all the key value pairing. That's basically metadata that doesn't convert over to the external one. So if you edit this and edit your raw map file and then run EQ EQZXC targeting the directory, it'll also repack it into the S3D for you. And by doing that, you don't have to use any third-party GUI. It's purely headless, EQZXC, right? And you just target the path or target the file, and it does extraction or compression. And that's the vision. Because like EQZone or OpenZone is great and all, but everything that it's doing ultimately can just be done third-party, in my opinion. So that's the hope. I want to just get off of the OpenZone pipeline and use something like this instead. So the first step for that, of course, is archive management, which is what I'm working on right now. So yeah, and what I'm working on right now is I'm actually looking at the PFS file that I generate and making sure it's similar to the PFS file that it was sourced from, which I can already tell you I have some pretty big flaws going on between the two. My compression, I know my block chunk compression's messed up, including my header entry here, 1, 2, 3, 4. It's off, but that's okay. I'm about to run a debugger on that. And then you got the PFS header with the 20 afterwards. Then you have 0002. Those are close, or they're actually the same. And then the next entry is actually already off. I'm curious if the footer is the same. So I do have Steve. I have an extra E for some reason. I guess the 45. Oh, that's my 69. So with him, he's putting 4 bytes, and then I guess there's a plus on the end. Mine does as well. Okay. Which is the EOF marker, I guess, on this hex editor. So is the end goal opener zone or more just a direct translator between professional modeling programs and EQ zones? So the end goal is to hopefully make map editing and just general EQ management simpler, right? So to start, I'm trying to get WLDs locked down, which is an open zone world, right? Like an open zone scenario. But down the road, I'd love to just take pretty much every type of file type and use TOML to basically be like a GUI for you to define properties and references or whatever, so that I can take a raw format file that you can open in a third-party program and save, and then with the help of the markdown file, recompress it back to the S3D. And then the reason I'm doing it this way is this is super easy to version. And this is super easy to edit and work with, where like OpenZone, it's a bunch of clicks every single time you want to do an export operation or an import operation. With this, once you have it done, you just run the program. And you could even chain that potentially in your third-party program, right? The third-party program could execute a batch file, or I could potentially write a plugin so that in that program, you just say save, essentially, and then you go in game and you see your changes, right? That would be the dream, right? So yeah, for the time being, I'm actually not really targeting professionally modeling programs yet. I'm actually more targeting probably a BSP editor. So NetRadiant, maybe Hammer. I'm still debating if the conversion between WLD to BSP, or sorry, WLD to like GLTF is clean enough to be worth the effort. But I'm totally cool with like actually making both of those file types, right? Where maybe in EQZXC, you can specify an option to say export world files to, GLTF. So then you can import it into whatever 3D program you want. And then I'll use that as my pipeline. Or you could say export it to BSP types, right? Which would be .map files. So anyways, yeah, you can see here, my program, I have a bunch of like partial work all over the place. Like WLD file support, I have a lot of code, but it's pretty much pseudocode right now that parses every single type of fragment, actually loads the world file, and basically puts it into a a struct that I'm ready to go to convert it back and forth with. Yeah, because a lot of these programs, even OpenZone, it's just, I mean, OpenZone's the closest to what we want, but it's still, like, it doesn't parse S3D files, for example, right? It only exports out to S3D. It doesn't actually open S3Ds or WLDs, right? It has 0 bidirectional support. And that's my whole goal with EQZXC, is the extraction and the importing of content. Because I figured the easiest way for you to learn something is go point it at a path of EQGs and S3Ds and whatnot, and just see all the examples that it creates out of native EQ zones, and then mod it, tweak it, and start writing your own based on that, and start making your own zones. So see all sorts of crazy custom zones if importing the original zones was an option. Oh yeah, I imagine this tool could be dangerous if too simple, but what we're going to probably need to do eventually is create server-side CRC checks to make sure the zone files are in sync with what they should be. That should be in place anyways, but that's down the line, and this is not nearly in any state where it's usable too well. Well, I mean, you can't just go into OpenZone and say open S3D. That's what I'm trying to say. And even just OpenZone's natively supported features, like I want to make an S3D. Yeah, because look, it only supports SCN, or if you go to import, there is no S3D option or EQG or WLD, right? There's only 3DS, right? There's Ogre XML Mesh. There's Quake 3 maps, which is the one I like the most so far, and animator related data. Which, have you messed with that stuff yet, by the way? I did yesterday get one of the Beatles to work in game. And then when you do export, especially to S3D, this prompt is every fucking time. You can't store this as a feature. Then it has like 3 confirmation boxes, and that's every single time you save. And that's just unacceptable in my book. I want all of this to be no prompts. If there's an error, it'll output that during your processing, but otherwise just green light it. You know what I mean? All your settings should be stored. Like, even the file that you're compressing is determined by what you call this. So like, if you want this to save as an EQG, you just change the extension to arena.eqg, and that'll tell EQZXC when it parses this directory that this file should be stored as arena.eqg. You see what I mean? And so this reflects one-to-one and can be versioned easily in a GitHub repo, so that, as you edit it, you have all of your raw files, and you could private repo that and then just generate S3Ds off of it and essentially just work on these raw exports. That's the whole vision I have.
All right, he's usually not this bad in the morning, but today is exceptional. Trigger.
And 1 second here, I'm looking. I got a work message. I'm just checking if it's anything important. Something about updating one of my SAW devices. No worries. So anyways, that's the goal. Even like these BMPs, a lot of them have, for especially transparent BMP files, they will put on the top left pixel what is the transparent color. I don't think the Arena has any. And anyways, they're kind of doing a hack to do transparency for like trees and such. That I would actually like to put into the TOML file. So then you could potentially work, like I'll do the conversion of BMP to PNG or something. And during the compression step, I'll do an auto conversion from whatever, like a PNG which supports, ARGB, and turn it into a .bmp with that top left pixel restored to be the transparent color reservation. And that data, as far as what the transparent color reservation and even that step, would be stored in a TOML file So you have full, manipulability of that without necessarily having to open up an editor, right? You just edit text files. That's kind of my vision. And, there are a few other tools out there that Zayla has made over the years that are awesome. Like his, where is it? The texture. Oh, this is, by the way, just like a one-to-one open zone source thing by Windcatcher. Yeah, this is literally just a one-to-one of one of the markdown files. Now, Zayla's tool has, like, for example, texture adder. See, all of these features and options and settings, I would love to just dump this, right? The MDF, export, all this stuff into TOML files. So then you're not having to open up this program, reopen the file, click on the entry, and then, click on the properties. I want all of this just to be on a flat file. So when you do change the value, right, it's stored raw. And then during my conversion step, you just can, flag all this data, especially if I can't get this easily put into like metadata of a, in NetRadiant or Hammer, or even in your, 3D Studio or Max, and I want that because GLTF does support metadata, but it seems a little limited. Like you can support, there's no string from what I could tell. There's only, where was it at? Yeah, you have properties, and apparently you have string, but I know that Blender by default does not support that. 3ds might, but I want to move to GLTF. It's so much easier, in my opinion, across the board, especially non-binary. I'll probably just make it so you have to export as a raw, whatever, text GLTF, I think it's what's called, or plain text. Because there's a bin version, but, worst case, I can add that later. So anyways, right now, my goal eventually is to make it so that my out file is going to be matching my in file. And that's going to take some time. My chunk system is still jacked. I think I need to just start the debugger here real quick and review how I'm doing a compress operation, because I'm obviously doing something wrong with my chunk generator. And I'm not fully sure what I'm doing wrong yet. This deflate chunks operation, this code is not working as I'm hoping. And this one, I'm not fully sure when it does compress chunks. I think it's up here somewhere. I think set contents does it for directory. Yeah, you can see here uncompressed data, get set. They do this length, then they go through and they iterate. So I'm going to mark this. And then I'm going to go back to EQ whatever and do the same thing. Then let's go to a test. Let's run the debugger. And we can continue from here. All right, so now we're in the chunk debugger. Let's do the same thing for this. Start. Open up the arena. There we go. Let's save it as test.s3d. Save. All right. This breakpoint we don't care about. Next. We don't care about this breakpoint anymore. Or these. All right, so now we are close to the same spot file-wise. Somebody messaged me. What's up? Doing some Apex later. Sounds fun. All right, so we're going to be deflating a DDS file. And in this case, we're going to be deflating... it doesn't tell me... Okay, wait. 68, 68, 83. Oh, wait, this is the wrong chunks. Let's go ahead and continue. We braked at the wrong spot. I want to do deflate chunks for the directory. This one. So what we're going to do is temporarily uncheck this, hit continue. Now we're going to breakpoint inside and hit continue. Okay. So now the data is path data. And I think this will match. Yeah, see 10, 0, 0, 0, 0, 0, 9, 0, 0, 0, 99, where this is 10. It's not going to be 1-to-1, but I want to see how this chunk data system works and how they differ, because something is different. All right, so let's go ahead and continue. Data is not null. And a lot of this is just being initialized, so the data is, like uncompressed is 158 on this one. And on here, chunks total size is 0. Oh, well, I haven't set it yet. Data size is 54. Interesting. Why would the difference be so high for set contents? Can I see this full picture, or is this? I think this is truncated. Yeah, I think I have something already messed up with the deflate chunks function, because this should be the directory buffer, which should be based on the number of files. I'm a little confused why this buffer is not big enough. Because at this point, 158 sounds closer. Because you can see there are 10 entries. In each entry, well, let's go ahead and I guess rewind here a little bit and go back to here, because I could already have a bug. And see, even this, when I'm debugging, the fact that I can just go into my little test program and hit debug, and it immediately puts me in the code to exactly what I want. Where on the S3D program, I have to do the file operations. There's no test files whatsoever. So I can't target test yet. That's annoying. Anyways, so the number of files is 10. And it's basically all the BMP files and WLDs, right? And for you, the number of files is 10. And the same sort of thing. CLA, DDS. Ooh, it could be doing a conversion, actually. I should double check that. That would explain why they're different. Let's go ahead and start it. Go to preferences. Yeah, we don't want those on. I want it raw. That explains it. All right, so Arena, S3D, open, file, save as, test.s3d. Save, yes. Okay. So the call stack shows now that the data is now 158 still. Okay, so we still got a big file. I'm going to double check some of the contents. So we have a stream we're writing out. I really should have set a breakpoint like right here. Let's do that actually. Open, arena, save as, test, yes, okay. Now, we have 10 files. The first entry, which is about to be iterated, it's doing it per character, and it's also putting the length before. So let's kind of follow the code on both. So we have claw that's being written on here, and we have claw also being written on here, which again, it's doing image format DDS. That's interesting. I must be that those are just default values. But let's see what it writes real quick, because the stream right now contains, I can't see a raw buffer. Oh, it already has 10 and then a bunch of zeros padded. And that might be this being written to it right now, because it should be writing a 9. And mine is writing the length. Well, I can't even tell what that is. What is that? 1, 2, 3, 4, 5, 6, 7, 8, 9 as well, I think. Yeah, 8 plus 1. So they both write. Then they finish it with a dot. Is this put into a buffer that I can preview in the stream over here? Probably not easily. There is a buffer defined here. Okay. And this, let's hit continue. And we can do a quick, damn it. Let's resize you back to small wall. Okay. So what we're going to do is just peek at this and see if we're still accurate, because we should be identical so far. 10, 0, 0, 0, 9, 0, 0, 0. Yep. But see, this is writing 99, 108, etc. It's actually writing out the characters where mine is not. Oh, that might be why they're not in sync so far. Because if you see here, this is iterating every entry of the character. So, am I not? I am not. All right, well, that's easy to fix. Cool. Now, continue. We write this, and now the buffer should equal. So 10, 0, 0, 0, 9, 0, 0, 0, 99, 108, 97, etc. to 112, 0. Yep, we are exact now. Cool. Now we continue another buffer write. And you can see here, it is writing out. Okay, so we're going to go ahead and continue. I'm pretty sure these are relatively the same so far. But that explains why the buffer... Oh, wait, there's doing a set contents call. Is this happening every... No, this is after the files are done. Okay, so we can hit continue, and we can hit continue, and now the stream has quite a bit of bytes on it. I don't know how many, because this buffer is gross, but I can probably see it easily over here. or not so easy because it's in directory buff. There. So the length is 158 now. Okay, so now we're actually a lot more accurate with what I wanted earlier. So let's go ahead and continue. 158. And I'm pretty sure this is also 158 right now. Isn't that correct? Yes. Okay. So now we're going into the chunk writer. And this is the area that I'm not very confident in because Go does not actually support chunk writing, at least in the examples. So I've kind of pseudocoded this. And frankly, it's not going to probably go very well. So I'm going to put some breakpoints and we can walk it and let's see how comparable they are now. So data is not nil. Image is not needing to be checked. Size uncompressed is less than block size. Then size uncompressed is the block size. Okay. So with us, we do the same thing right here. So let's continue. So data size is 158, and I do -1, where he just does 158. So I don't need the -1, I don't think. Then max block size, which I just hard-coded at 8192. Then block size equals then chunk size equals whatever this value is. Let's press continue real quick. So it creates a byte array exactly the size. Okay, so chunk bytes is now 158 because that's exactly what it wanted. And what I'm about to do is take data from the index, which is 0, and then take plus 58. So I think the block size, because it's an index, this might go out of range, but let's see what happens. And then this code is doing some odd things. Let's see. So while uncompressed is less than length, it's iterating this, creating chunks. And this is causing uncompressed to go up? No. Data length minus this is less than chunk. Does this value get increased now? Yes. So add chunk causes data length to increase. I really hate when things do crap like that. Add chunk has, how does it reference data.length? It must be, I don't see it. Yeah, regardless. What I'm really curious about is the data that it just wrote is now compressed. And it writes that into chunk. Shit, I lost that function. All right, what does add chunk add to? It adds the chunk to status? No. It adds it to compressed chunks. So compressed chunks has an array, and here's the 2 data points. So when this gets compressed, it's at 102, I guess out of 158. I don't know what that 102 out of 158. Oh, that's the 2 value types. Okay, so we're about to hit a similar area in this code. Let's go ahead and continue. In fact, let's go ahead and jump to like here. So we have a comparison here. Compressed chunks should be 158 uncompressed and 102 compressed. We have 158 uncompressed and 2 compressed. So we are obviously not doing this right. So let's go ahead and stop this, because I did do some edits, and see if we can figure out why. Namely, I edited how this entry works with the block size. Yeah, if data size is less than chunk size, why is it not? Why is data so damn huge? Oh wait, this is the DDS. Ah, crap, this is going to be a pain. Let's break out of all these. Hit continue. Oh, we got a panic. And that's because, yeah, I kind of figure this happens if this value needs to be -1. Since I'm doing a slice. No? I'm still out of bounds. Interesting. How did my code cause out of bounds? Now it's saying I'm out of bounds at a different area though. Or is that just how the stack trace panics? Yeah, where's my stack? Do I get a stack? Well, I mean, it's in here. Test, PFS, deflate chunks. It's crashing on line 74. Yeah, so this block size is, yeah, it's out of bounds because data size is not less than chunk size. Let's breakpoint this real quick and see if I can find when this exactly hits. Okay, so we're doing 0 to 8,192. You know what it is that I'm incrementing by block size. So I'm skipping a byte, I think, every entry. That aside though, why am I still? That wouldn't make sense on why I'm crashing. So slice bounds is out of range with capacity. So slice bounds data size is based on length. Data size needs to be updated on each iteration. In fact, data size needs to equal the length of data minus I. There. I don't know if that really fixed it, but it stopped crashing. Okay, let's go ahead and run another debug now that we're at least past that step. Now we go into PFS, we add a breakpoint, and we can continue debugging here. All right, bring you back over here. So we're looking at the first entry in data. Damn it, this is still dirt. I don't want dirt. I thought this triggered on here. No, these are the names. Claw, dirt. Okay. Okay, we're good. We're good. All right, so we're going to hit play. Boom. Now, block size is the inflated side, which is 158. This should be more than 2. Like, what's going on here? We're taking I, which is 158. Oh, is it writing a second chunk? Is that what happened right here? Let's check that again real quick. Let's debug. All right, so we're writing it out. We're gonna break here, hit continue. Now we're stopped. Okay, so currently I is 0. So 0 plus 158. So the whole data size is pretty much the whole thing, right? So we're taking that, we're putting it into the zlib-writer, and we're writing it out into buffer. And the buffer bytes goes into data. So you can see there's a bug right here. The fact that my data churns into 2 bytes when compressed does not sound correct. Why is it doing that? Let's see. Buff is based on buff bytes. Honestly, I think the buffer can be rewritten each call. Don't think that's going to necessarily fix or break anything, but that is technically a bug. Okay, so we're back in this code. We're going to hit continue, or step. And we're going to go to here and hit continue. Okay, so deflated size is still 2. How the hell is zlib-writer? Let's do this actually. A dump. This is going to be really spammy, which it already is, but we're going to take this off, hit continue. It's spammy because of every single data entry is going to be spammed out here. But now that we're done with that and we hit continue, boom. So you can see here the raw data wait, why is this? Hold up. This is so big I can't tell where this entry starts. But basically, this data here should just be the 158 and be like 10, 0, 0, blah, 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 and end with 119. You'll notice this, though, I debug print, and it ends with 0, and it's fucking huge. And it starts with a 198, it looks like, potentially, or there's just multiple entries. That's weird. %, just pseudocode, just so I can run a quick debugger. Oops. And apparently something's problematic with that. That's fine. Can you just run the test? Oh, I think that's the debugger still running. Stop the debugger, cancel, debug. Okay. So now we get raw data, right? We can go and pause that or take that out. Now we're in the directory chunks. We can just pause here, hit go. All right, so here's the 158 bytes, which is exactly what we wanted and ends with 0, 0. Okay, so yes, I've confirmed that my zlib-writer is literally just getting the data that it should. So my chunk writer is not working because the zlib-writer is only writing 2 bytes. What's going on? Yeah, it starts a new writer. And the write function should tell me the number of bytes. N. Why is this an issue? Oh. Okay. Pretty sure my compressing tool is fucked up for some reason. 8192 is not. But that's 1498. That's interesting. Anyways, we're going to go back in here. Now we're in the buffer. And it says compressed equals 158. This could also be the bytes read. We can go look at that real quick. N, compressor write, data write, N equals the length of B. Oh, yeah, that's the number of successful parsed bytes. So we know that it's parsing all the bytes properly. But the output... Do you think my writer needs a flush? I don't think zlib new writer needs that, but let's do it real quick. Yep, it has a flush. That might explain it. Okay. So let's go ahead and run debugger. Okay, we're at the point that I care about. Let's hit play. Does flushing change the deflated size? Yes. Fuck, there you go. There was the answer. Without flushing, it doesn't actually write, which is why you only get the header, which is 2 bytes. Cool. All right, so now if we come over here, we have compressed 102, and this has 103. I think the offset is maybe because length increases it by 1. It's a little sus. Can I see the compressed bytes and do a comparison here? What I'm really curious about is what is the last value? Since it's only 102. Okay, so at 101, it's 4139, right? See, I have 255, 255. In fact, this whole compression schema looks different. Shit, let's see. I'm not sure the easiest way to compare. Can I please just get like raw byte data? Is there a way to do that in here? Like, I don't need a byte array to be like this. I need it to be a dump. But okay, 88, 133, 61, 204. Totally different header. Interesting. So my zlib reader and writer are writing differently, I think. But you know what? Let's continue. It's close enough, right? Let's just say it's close enough. And in fact, let's just continue the whole process. We're going to go ahead and write it out. Just write the file. And let's do a quick A/B on it. Hex editor. This is my out. And this is my in. How are we looking? We are looking much better, at least in the data. There's not like a bunch of padded X's anymore, at least. the directory index is off, or like significantly different. The 2 byte is proper, and then the 2.8, this is totally different. How's my footer looking? We already know that the footer was okay. So my file has shrunk significantly by like 1600 bytes. I'm guessing I lost data, but we are on the right track and we are getting farther along. So I'm going to go ahead and commit this, and it's just more stuff to do later. So there was a couple things I changed. I added a CRC fix, which was really just adding a 0 appending on the end. Fixed CRC check or generation. I think I actually have a ticket for that pending right now. Yes. Oops, I should have referenced that, but that's all right. Then this, what are we going on over here? Let's see. Load, I didn't do anything. I just added a line. PFS, I did the whole chunk changing, which is closer to proper. And then save, I did a huge revamp. So I'm going to do added more to PFS save. And I should reference, but it's all right. I don't know if push and pull work in here. It might prompt me for GitHub. Yeah. GitHub is horrible sometimes about, but here I can hit fetch and pull and I'm fine. Cool. And then this I can say fixed with this commit. Cool. We still have a number of issues that we're trying to get made, but that's progress. Quite a bit, actually. Not too bad. How long did I stream for? An hour and a half. Not too bad. Anyways, if you've been watching, hope you've enjoyed. You can see my processes of doing A/B testing between C# code and Go code. And yeah, once I even get the S3D steps done, I'll probably start as a mini milestone working on the WLD like this, the transparentifier, and being able to tweak this. And there's also a texture swapper, or they call it texture adder. I might see about adding these functionalities to EQZXC because those are a lot easier, you know what I mean, while we're waiting on the full WLD processing. And this will be amazing because just these edits alone, I can start editing existing textures on my custom server, especially like Dark Elf and whatnot. And yeah, that's it.